Okay, Module 3 of the SRE Practitioners course, we'll talk about system design and different characteristics of good design relative to making things reliable, scalable, even though the SRE role isn't necessarily, an architecture role, but being aware of the different architecture, system design strategies, and participating in those strategies together with development and architects and so on is something that really good SREs are typically involved in to make sure the systems are built according to uh, practices and capabilities that will be make it easier to operate, scale, and have reliable systems in production. So the module has several design methodologies that we'll talk about. We'll do a number of exercises as well. One of them is called the non-abstract large-scale design approach. There's something called the fault-tolerant design patterns. We will talk somewhat about DevSecOps and designing for security. And finally, different strategies for designing for resiliency, scalability, performance, reliability, and security. This module has a similar structure to all of the others. There's a video, Building Secure and Reliable Systems. There will be a case story around the Google Chrome security team. We'll actually do a fairly significant discussion and even an optional homework assignment around non-abstract large-scale design capacity planning. So we'll spend a fair amount of time on that particular model. Now, this chart really explains how SREs can participate in the entire software and service lifecycle. In general, it's a good idea to have, if you look at the y-axis, the level of SRE involvement should actually be concentrated, even though it's a role to help with production. By getting deeply involved in the architecture and design phase, you can save yourself a lot of effort, concerns, and avoiding problems later in production. So during that initial phase of a product design, SREs definitely have a role to play. During the development phase, when product is actually being translated from design into, coded into a product, still want to participate in that to make sure things are being implemented according to expectations from the design. And then during the introduction phase, of course, SREs are involved in taking the new products through their alpha and beta testing and into general availability. As products get more and more mature, then hopefully there'll be enough automation and capabilities in the product itself where the SREs can, don't have to pay as much effort and attention because they're more self-sustainable by that time. So that's sort of a view of the life cycle. Just these notes pretty much say the same thing, but I'll repeat them because it's important. This kind of describes to some extent, the why SRE should be involved in in architectural aspects. So at the application level, having SREs embedded with development teams can ensure the application components, design of the application, and new releases are built in a manner that will not disrupt reliability and hopefully will improve and support reliability. SREs can then focus on application level objectives, error budgets, and integration into DevOps pipelines. What you don't want to have is a situation where a product gets released and it doesn't have the capabilities you need built in, and all of a sudden you're having to backtrack and build those things in order to get, let's, for example, observability, for example. System level, at the system level, assigning SREs to focus on the product release train, individuals supporting launch coordinations, evaluating system architecture readiness. So you may have some metrics associated with that are specific to an application and the system. Generally ensuring organization meets the system-wide application SLOs. And then at the enterprise level, which is, again, broader than the system, establishing an SRE Center of Excellence is a good idea to try to have some collaboration across the different applications and try to set some design standards, for example, operating products and platforms according to some successful, proven successful standard frameworks, maybe templatize configurations as code, develop your best practices and tools and resources required to support the SRE function across the whole company. So let's talk about the first architectural framework. There are many out there, but this is a popular one. It's called non-abstract large-scale design. The NALSD is the short form for that. So it describes skills critical to SRE, the ability to assess, design, and evaluate large systems. And this is something, again, that you want to become familiar with as a good SRE. The NALSD framework combines elements of capacity planning, component isolation, system degradation strategies. These are all critical to making sure products are going to be available and reliable in production. This approach turns like a whiteboard design into more of a concrete set of estimates of resources that can be used to build real-world systems. The general idea is begin with a clear understanding of the problem, gather requirements, iterate through different designs that become increasingly sophisticated until a viable solution is found. So in other words, use engineering approach to dissect and analyze and suggest and make improvements to the design as it's being built. Ultimately, the aim is to arrive at a system that defends against many failure modes and satisfies both the initial requirements and additional details that emerge during the different iterations of the design. Okay, we're going to do an activity. This is a fairly large activity. We'll allocate 45 minutes. I'll give you some instructions, and then this is something where you can do on your own. The activity is really to take an example of a large-scale design and walk through it so that you can understand the approach. There's actually two possible approaches. You can actually do hands-on exercise, or you can actually just run a video to understand it, and that's what we're going to do in this self-paced course. I'll leave it up to you as a homework assignment if you want to go through the equivalent exercise activity as a hands-on course. So I'll play the video for you. And generally what the video is going to do is show you how SREs would contribute to a large-scale design. And we'll be using an example of creating a distributed server from Google. So the video is a Google video. That's a good example. And we'll talk about, and you want to learn, really your learning target is to understand what are the key principles that need to be followed to ensure reliability of a system as it's being architected and designed.